Hello everyone, welcome in today's lecture. Before this video, we have seen the videos of Zeeman effect or the atoms in magnetic field, how the atoms behave in magnetic field. So in this case, there are two type of effect, Zeeman effect we got, and there are two type. This effect we generally know, which is normal Zeeman effect and anomalous Zeeman effect. So anomalous Zeeman effect is which occur in presence of weak magnetic field and the split up line spectral line split up into two or three or more lines, and which is not equidistant. And for normal Zeeman effect, the effect is occurred when total spin angular momentum is zero, so which can be explained by only orbital angular momentum, or total orbital angular momentum is equal to j. And source of normal Zeeman effect, calcium, copper, helium. And for anomalous Zeeman effect, which is the atoms of alkali element like sodium, potassium, chromium, which exhibit anomalous Zeeman effect. So today we are going to learn about the explanation of normal Zeeman effect by using classical theory. So the normal Zeeman effect was explained by classical theory using Lorentz force. So as we know that Lorentz force is the force of electric and as well as magnetic. So electric force is charge, velocity, charge into electric field, and magnetic field is charge, velocity and magnetic field. So magnetic force is QVB. Now, as to explain this Zeeman effect, we consider electron of mass m, charge E, which is revolving around the nucleus with some radius of orbit, that is r, with velocity v0, initial velocity, and the centripetal force which can be revolving in an orbit. The centripetal force is F0. So as we know that centripetal force is mv square upon r. So the velocity is v0, so m v0 square upon r. And when magnetic field is applied, so magnetic field is perpendicular to the plane of orbit as shown in figure. So the magnetic flux link with that orbit, and what will change? It will change the tangential electric force and induced on electron, or the tangential electric force induced on the electron. And this tangential force can increase or decrease the velocity of electron. So whenever the magnetic field is applied to atom, the tangential force increase or decrease the velocity of electron, but the radius of orbit, to keep the radius of orbit constant. So the electron experience Lorentz force, which is equal to charge, velocity and magnetic field. So it is a cross product E V cross B. So in case of this force is radial, and it will increase or decrease the radius of orbit. So the tangential force, first case we consider the tangential force increase the velocity of electron from the velocity v0 to v1. So the increase centripetal force, or that is the final centripetal force to move the electrons in same orbit with velocity v1. So force F1, which is equal to m mass v1 velocity square upon r. And now the additional centripetal force required. So additional force, which is the difference between two forces. So F1, which increase the velocity, so initial velocity is V0, so the centripetal force difference or that additional force can be required F1 minus F0. So we have the F1 is mv1 square upon r minus mv0 square upon r. So this is the additional force which balanced by the Lorentz force, that is nothing but the EVB or EV1 cross B. So F1 minus F0, which is equal to magnetic force, which is given by E V1B, and there is a sine angle, so sine 90, which is because of the perpendicular, sine 90 equals to 1. And this terms velocity we can convert, or we can write in terms of frequency nu. So as we know that v equals to 2 pi r, v means that is the speed, so 2 pi r upon t, so 1 by t is nothing but nu, so 2 pi r nu naught for first frequency, and for second frequency is 2 pi nu 1 into r. So by putting this value in above equation m, that is v, that is 4 pi square nu 1 square r square upon r, so 1 r get cancelled, and another which is equals to e, the value of v1 is 2 pi nu 1 r into b. So from this case, this r get can 4 pi square nu 1 square mr minus 4 pi square nu naught square mr equal to 2 pi e v1 rb. Now this whole equation dividing by 4 pi square mr, so we'll get on this left side nu 1 square minus nu naught square equal to eb nu 1 upon 2 pi m, then 2 pi m. Now this is the one of the quadratic equation in variable nu 1, and its solution we have to use, that is ax square plus bx plus c equal to 0, and the solution is x equal to minus b plus or minus under root b square minus 4ac upon twice a. So similarly here the b terms is nothing but minus eb upon 2 pi m equals to 1, and c equals to minus nu naught square. So putting this value carefully, if we perform the mathematical operation, you will get the correct answer. So nu 1 equals to minus minus get become plus, so which can be, now we can multiply and divide by 2, so it will give become 4 pi m on denominator, and in square root we can also first terms divide and multiply by 4, so this 4 can be common out, so from square root it will come out of 2, there is 2, so divided by 2 whole, this 2 will cancel out, so we'll get this terms nu 1 which is equals to this 2 to get cancelled, e b upon 4 pi m plus or minus under root of eb upon 4 pi m, that is whole square plus nu naught square. Now in this case our nu 1 eb upon 4 pi m plus or minus eb upon 4 pi m whole square plus nu naught square, and since in square root bracket there is two terms eb upon 4 pi m whole square plus nu naught square, so these terms eb upon 4 pi m square is very small as compared to the nu naught square, so it is neglected, so we get nu 1 equals to EB upon 4 pi m plus or minus nu naught. Or if we take nu 1 minus nu naught, it is equal to EB upon 4 pi m. So nu 1 minus nu naught is nothing but delta nu Zeeman shift equals to EB upon 4 pi m. So that can be proved. Now another, when the tangential force increase the velocity from nu 1 to nu naught to nu 1, so the maximum velocity frequency is nu, it is frequency or velocity. So frequency increase from nu naught to nu 1, so nu 1 minus nu naught, which is equal to EB upon 4 pi m. Similarly, instead of increasing the velocity, when the velocity decreases from nu naught to nu 2, so we get similar equations as nu 2 minus nu naught, which is equal to minus EB upon 4 pi m, or nu naught minus nu 2, it is equal to EB upon 4 pi m. So hence we can prove this Zeeman effect, the Zeeman shift, the separation between two successive frequency equals to EB upon 4 pi m. Now how we get this polarized light on two view, perpendicular view to magnetic field and parallel view to magnetic field. So in first case, if we consider the spectral lines coming in y direction and magnetic field is applied to x direction, z direction is perpendicular to this field, that is perpendicular to the plane of paper. So to explain the polarization of Zeeman effect, the component in parallel and perpendicular view, when we view perpendicular to the magnetic field, that is in y direction, so the only x and z components, so we are viewing in y direction, so another component, that is x and z, which are effective with sending the light in y direction. So the magnetic field in x direction, so which will produce no change, so there is no force, there will be no change in the spectral lines or the plane of that state of light in x direction, so there is no change in the x direction. So we observe nu naught in this case, the frequency of spectral line nu naught, due to this component that is in horizontal plane of vibration. Now the magnetic field, now another we observe nu naught, then the z component which is acted by the magnetic field, so z component of that spectral lines is affected and which displaced into two components, that is nu 1 on left side and nu 2 on right hand side. So we get delta nu according to this classical theory. Thus we get three components, that is nu naught in x direction and nu 1 and nu 2 in z direction. And in another case, when we view, observe the spectral lines in parallel to the magnetic field, that is on x direction, so there are two components y and z's that are vibrations that is affected by the magnetic field. So we obtain these two components of spectral lines nu 1 and nu 2, and this nu 1 and nu 2 having two component in y component and z component, so which can be superimposed with each other and produce circularly polarized light, and in that case nu naught is not observed. So this is the explanation of classical explanation of Zeeman effect. So in next lecture we will study about the Zeeman effect on the basis of quantum theory, so the explanation of quantum theory to the Zeeman effect. Till then, stay tuned and study well. Okay, thank you.